Assalamu alaikum. Welcome back to this channel Being Physio. Today we are going to learn penicillins. So what are penicillins? Penicillins are a class of antibiotics which were discovered by the great scientist Alexander Fleming. While working in his lab, it is in 1928 when he observed that a culture plate which was contaminated by some mold. He observed that the growth of the Staphylococcus in the vicinity of this mold was inhibited. And he began to think, and finally, he obtained the pure culture of this mold. Finally, he obtained the pure culture of this mold and came to the conclusion that this mold secreted some substance which he named penicillin. And in 1941, this penicillin was first used in humans and it had the property of inhibition. It inhibited the staphylococci. And since then, we are using frequently these penicillins. So this is some history regarding penicillins. So what exactly are these penicillins? What is the chemical nature of these penicillins? In order to learn the chemistry of these penicillins, I want you to remember just a, a little trick. You just remember a home which I called the sulfur home. You have to remember this is the sulfur home which contains the roof made up of sulfur and a path, a beautiful path made up of carboxylic acid. It has a side room attached to the sulfur house. This home you can remember, at least this home you can remember. This is carbon sitting here, double bonded to oxygen, and here is the beautiful entry for this home. This entry is made up of nitrogen. And here is also a carbon, here is also a carbon, and this is carbon sitting here attached to other groups, and here is the nitrogen, another nitrogen, NH, single bond C, double bond O, and to this carbon is attached the side chain, or this is the side chain. This is the basement, this is the entry, this is the path, this is the path of carboxyl pathway, and these are its windows. This is the sulfur home. I think this is very simple structure you can remember, and by remembering this structure, you will be able to remember throughout your life the basic structure of penicillin. This is the basic penicillin structure. All other penicillins of all other groups are derivatives of this basic penicillin, and the derivatives come by changing this side chain, or here this side chain I call the antenna. This is the penicillin home, this is its antenna, these are its two pathways. One is carboxylic acid pathway and another is oxygen pathway. You can enter through this way or through nitrogen way. And this is the basic home, this is the side chain. And now let us see the let us go ahead, let us see the mechanism of action. What is the mechanism of action of these penicillins? The mechanism of action is very simple. There is an enzyme which is called transpeptidase. Transpeptidase. This enzyme is responsible for the reaction transpeptidation. This reaction is responsible for the synthesis of cell wall of all bacteria. All penicillins inhibit this transpeptidase. When it gets inhibited, cell wall synthesis stops. Cell wall synthesis stops, cell wall deficit forms are formed. Cell wall deficit forms are formed, and this is the bacteria without cell wall. The interior is hypertonic, and osmosis of water will occur, and osmosis will occur in this cell without cell wall, and finally it will become turgid and will burst lysis will occur. This is how penicillins exert their cidal action. They are called bactericidal drugs. This is how the bactericidal action is achieved. They inhibit the transpeptidase enzyme. Where is this transpeptidase enzyme? This is located in the plasma membrane of all gram-positive and gram-negative bacteria. It is responsible for transpeptidation reaction. When this is inhibited, cell wall deficit forms are formed, and cell wall deficit forms are formed, and that and osmosis occurs, the rigidity increases, lysis occurs. This is how cidal action is um, occurs. So let us go ahead. These bacteria are very clever. They have developed some resistance, and there are different mechanisms of resistance. For example, if this is the bacteria, this is the plasma membrane, this is the cell wall, and this is the outer membrane of gram negative. This is the plasma membrane, this is the cell wall. Gram positive, gram negative, gram positive. This is the outer membrane. This is made up of phospholipid bilayer. This is the cell wall. This is the plasma membrane of bacteria. Plasma membrane, cell wall, and this is the outer membrane. The cell wall is made up of peptidoglycan, and this transpeptidase enzyme is located here. This is the transpeptidase enzyme. And this is the outer membrane made up of phospholipid bilayers. And in gram-negative bacteria, there are purine channels present in this outer membrane. This gram-positive bacteria, it do not have the this outer membrane. Gram-positive bacterium lacks this outer membrane. So the mechanism, this first mechanism, that is the alteration of these protein channels or purine channels, it is not seen in gram positive. It is only happens in gram negative bacteria. They alter the structure of these purine channels, so the antibiotic must have the right charge and size in order to sneak through these purine channels and reach this transpeptidase enzyme, which is located on the cell membrane. So they alter the structure of these purine channels. So this is the mechanism gram negative uses. So this is not the case with gram positive bacteria. Second mechanism is that both gram positive as well as gram negative bacteria, they secrete a chemical substance which is called penicillinase. Penicillinase. This is the enzyme which is responsible for the destruction of this beta-lactam. It destroys the carbon-nitrogen bond of the beta-lactam. This is secreted by both gram-positive as well as gram-negative bacteria. These are also called beta-lactamases, and they destroy this carbon-nitrogen bond. The third mechanism is the alteration of the enzyme transpeptidase. Some bacteria are very clever. They alter this transpeptidase enzyme. They alter the structure of transpeptidase enzyme so that even if the antibiotic is able to reach this enzyme across the cell wall and outer membrane, in case of gram negative. Even if antibiotic reaches this transpeptidase, they are not able to bind it because some bacteria have changed the structure of this transpeptidase. And the most notable bacteria, most famous bacteria which shows resistance uh, in this manner is the MRSA, methicillin resistant Staphylococcus aureus. This is the mechanism of resistance. So let us move ahead. So, what are the types of penicillins? There are various types of penicillins. First is the natural penicillins. Natural penicillins. It includes two members, penicillin G and penicillin V. Penicillin G and penicillin V. Both are similar penicillins. They both are similar penicillins. They are bulky penicillins. They have activity against all gram-positive bacteria except they inhibit gram-positive bacteria, except they inhibit gram-positive cocci, gram-positive bacilli. They inhibit gram-negative cocci, but they cannot inhibit gram-negative bacilli. They cannot inhibit this gram-negative bacilli. They cannot inhibit. This is an exception. So, what is the antibacterial spectrum of natural penicillins? They inhibit both gram-positive as well as gram-negative organisms, except gram-negative bacilli. Bacilli means rod-shaped. They are not able to inhibit rod-shaped gram-negative bacilli bacteria. So, penicillin G is acid labile. It is acid labile. Penicillin V is acid stable. Stable. Acid labile means destroyed by acid in the stomach. So this is usually given parenterally, and penicillin V is the oral form of natural penicillins which is available. Antibacterial spectrum of both is similar. So let us move ahead. Then after natural penicillins, we built another class of penicillins which are called the natural penicillins. Oh, sorry, which are called aminopenicillins. Aminopenicillins. What are aminopenicillins? The antenna in the basic structure is replaced by amine group. When amine group replaces the side chain in base of the basic penicillin, it is called aminopenicillin. In it are ampicillin, or two members, ampicillin, and amoxicillin. Well-known drug amoxicillin and ampicillin. These are the aminopenicillins. Both have similar activity as that of natural penicillins. They inhibit all organisms of as that inhibited by natural penicillins. Plus gram negative bacilli. I can write this way. What is the antibacterial spectrum of aminopenicillin is? They inhibit all bacteria inhibited by penicillin G and plus gram-negative bacilli, because gram natural penicillins were not able to uh, destroy these gram-negative bacilli, so they are inhibited by aminopenicillins. So I shall move ahead. Uh, the another class of penicillins is the third class, which is called beta lactamase resistant penicillins. Beta lactamase resistant penicillins. This is the third class of antibiotics. The side chains in these side chains, which in these beta lactamase resistant penicillins, they protect this carbon nitrogen bond here from the attack of the beta lactamases. So there are in order to remember the individual members in beta lactamase resistant penicillins. Remember mnemonic: I met a nasty ox with beta lactamase ring around its neck. The ox was very nasty, it was very dangerous. I met a nasty ox. This is the methicillin. This is the nephicillin. This is the oxacillin. All these are given IV parenterally. I met a nasty ox, and and the clocks were ticking. This is the second mnemonic. The clocks were ticking. Clocks means cloxacillin, dicloxacillin. Second mnemonic is just way to remember the individual members. So cloxacillin, dicloxacillin, these are oral forms of penicillinase resistant penicillins. These penicillinase resistant penicillins, they are the drugs of choice for penicillinase producing staphylococci, except MRSA. Except MRSA, when MRSA is eliminated from the medium, these beta lactamase resistant penicillins are the drugs of choice for penicillinase producing staphylococcus. So except MRSA. But remember one thing, they all are destroyed by the penicillinases of gram-negative bacteria. PEN, penicillinase of gram-negative bacteria. Gram-negative bacteria that destroy the beta-lactam ring of these beta-lactamase resistant penicillins. So this was the another group of bacteria. So the another, let us move forward, be quick and concentrate on the board. Another group of bacteria is the anti-pseudomonal penicillins. Anti-pseudomonal penicillins. This is the another group of penicillins, and they are very effective against Pseudomonas aeruginosa. Pseudomonas aeruginosa. This is the very difficult to treat Pseudomonas. They are very difficult to treat, and these are also active against the Proteus. These are also active against the Proteus. So these two organisms, these are not covered by natural penicillins or aminopenicillins. So they are covered by anti-pseudomonal penicillins. Gram-positive bacteria are resistant. Gram-positive bacteria are resistant to these anti-pseudomonal penicillins. So in order to remember, to remember these anti-pseudomonal penicillins, what they do, anti-pseudomonal penicillins send James Bond in order to destroy these Pseudomonas aeruginosa and Proteus. James Bond has three weapons. He has a pick of his car. He has a special pick of his car that is weaponed with some special that is guarded with some special weapons. That special pick of a car. He has a tick in his car, and has a pipe bomb which has the capability to destroy multiple targets. James Bond has a special pick of a car. Pick is an instrument used in agriculture, an agricultural instrument. He has a special pick of a car, a special tick in his car, and has a pipe bomb which has capability to target multiple to destroy multiple targets. This car here represents carpenicillin. This stick represents ticarcillin. This pipe represents here piperacillin. This multiple represents here meslocillin. Meslocillin. So these are the anti-pseudomonal penicillins, and they are active against Pseudomonas aeruginosa and Proteus gram-positive are relatively resistant. I'm going to rub the board, and the last group of antibiotics is the beta-lactamase inhibitors. Beta-lactamase inhibitors. It includes 3 drugs: clavulanic acid, sulbactam, tazobactam. This class of antibiotics, it inhibits the beta lactamases or penicillinases from both gram positive as well as gram negative. Gram positive as well as gram negative bacteria. Both penicillinases from gram positive as well as gram negative are destroyed. These beta lactamases are sometimes combined with another class of penicillins, like you often see amoxicillin plus clavulanic acid. Which has trade name Augmentin. And in order to provide the resistance against the beta lactamase to the amoxicillin. So we have finished the types of penicillins, and at last I forgot to show you the structure of natural penicillins. It is very simple. Instead of this antenna, when you change this antenna by a benzyl group, this is the phenol, when CH2, when this R chain is replaced by this benzyl group, you get penicillin G. When this R chain is replaced by, when you replace it by, this is called a phenoxymethyl group. Phenoxymethyl methyl group, you get penicillin V. And when you change it by amine, you get aminopenicillins. And I think this is not difficult to remember these structures of the penicillins. So this is enough for today. Thank you.